All right, we are all back. So coming up next, Holger Rutz. Besides David Pirro, he is the founder of the artistic research project Algorithms That Matter, settling at the IEM Graz. Also, he is part of the duo Anemone Actiniaria. We heard their piece yesterday as part of the first concert. And today, Holger Rutz will talk about the condensations of algorithmic spaces. Thank you.
Okay, thank you. Thank you, Janek Hoffmann, and also thank you, Ludger Brümmer, and the entire ZKM team for making this event possible. Before I go into the topic of the talk, I want to say a couple of words about ALMAT, which is our abbreviation for Algorithms That Matter. So if you want, I don't want to go too much into detail, so there is a link for you if you want to look up what the entire context of the project is. It is a project, as Janek already introduced, in the Institute of Electronic Music in Graz, in Austria, funded by the FWF, which is the Austrian Federal Science Fund. And they have a special program for artistic research called PEK. So this program runs, our research project already runs a year and a half, and so we are the two principal investigators. We have a couple of people with which we collaborate, and also we have embedded in this project an artistic research residency in which we iterate every couple of months. And so the last talk that you will hear in this morning's slot today from Jonathan Rose will be about his work at ALMAT. ALMAT's basic question is, it's always difficult to summarize in one sentence, but perhaps this is a good idea, a good way of formulating it. How do algorithmic processes emerge and structure the practice of artistic research, practice of experimental computer music or computer sound art? And what we're interested in is not algorithms as fixed entities which we take and use, but the way we engage with algorithms as a process. How do we come to use them? How do we come to react to what they offer us? So already David mentioned a bit the question of where an algorithm ends, or what is actually part of an algorithm or what not. This is even, again, a simplification. So in the middle part you have classical somehow definition from a computer scientist, Robert Kowalski, from 1979. He says an algorithm is basically you can divide it into two branches, one that go together. One is a logical definition and one is a control definition. So the control kind of says how an algorithm is performed, if you like, and the logic is kind of the formal way an algorithm is implemented. And that, again, you can take apart into definitions and data structures that have to be used. But all that it leaves open is in a way how this algorithm is coupled to some sort of environment, if you like. So what is the data that comes in? Also, who is writing the algorithm? What is the history of an algorithm? And so on. So that's kind of to say that we need to open our perspective on this a bit. The talk I want to give today focuses on the relationship between algorithms and spaces, and I want to approach it from the question of the aesthetics of algorithms. So is there an inherent aesthetics of the algorithmic? When I say the algorithmic, I mean algorithms as a sort of medium, or like something in which algorithms happen and are performed. One idea would be to say, okay, we can look at it formally. That's a bit how classical computer art also approached algorithms when it came into existence in the 1960s. So we have some classical principles. For example, short is elegant, something that can be condensed into a few things and then evolves is beautiful, either in the formal way or in the way we understand, so in the way we can perceive it or cognize it. There's also the term generative art, or generative art that you might know was, I think, I don't know if it was coined, but there's this whole catalog of what generative art could be by Margaret Bowden. So she says the possible space of computer-generated artworks is huge, indeed infinite. Moreover, most of the structures in that space will be images or music which the unaided human mind couldn't have generated or even imagined. So we are confronted with a kind of utopia, or with a kind of a problem, or with a kind of potentiality. When we write an algorithm, we can run it multiple times. It can run iteratively for a long time. So it has kind of the potential of this huge or infinite space of forms that it can produce. So that which kind of brings us back to the question of the aesthetics. So there's something missing. We have to kind of make a selection from that. So how does this become aesthetic? We need some additional intervention. I was attending last week an interesting presentation by a Graz-based composer, Elisabeth Hanig. She kindly sent me this from her presentation. It's part of a score of a piece called Reframing 2. And this is kind of an algorithmic score, if you like. It's part of a score. Each kind of note indicates a point where the musicians need to make a decision where they continue the piece. There's also these tiny numbers that indicate repetitions. An interesting thing that happened, I think it was in the premiere, at least as I recall, is that the musicians, they couldn't really decide what to do. And so they decided that they're gonna read the score from the left to the right. And she was not very happy with that decision, because obviously that was not how it was intended. So that's maybe to say that these algorithmic spaces, they need interpretation. So they are not self-sufficient, but they come with all our embodied knowledge, our expectations of how they're going to be used. I'll talk briefly about a piece called Grenzwerte, or in English, boundary values. Boundary values are ideational, gleaming from afar and may only be approximated. These horizons are not interesting through the acquisition, but through the traversal towards them. The piece is based on genetic programming of sound structures. It presents a conflict between natural and synthetic sounds. I'm attracted by the impurity or reality of the algorithm as an excess, the display of incomputabilities that fall short of or that transgress the set boundary, stirring up things. The process departs from the spoken sentence, Je vais donc essayer de me lire comme un autre.
Je vais donc essayer de me lire comme un autre.
This is the voice of Jacques Derrida, who is kind of making a radio reading of his own piece. What I did is I created a system that tries to approach a given sound, in this case, this sound that you just heard, by building synthetic structures and refining them through what is called an evolutionary algorithm, a genetic programming, which recombines the building blocks and tries to optimize that over time. Here are two examples. They are very far away from what you just heard. That's kind of visualized here as a kind of a PD patch-ish visualization on the left, or another one. So the problem is, again, that there's so many different sounds now. How do we organize the sounds? The evolutionary process is a basically indefinite process, like many of the algorithms that also David talked about. It's not about, it has a specific target that it wants to reach, but it is kind of impossible. With this given of combinators, it will take probably millions of years to rebuild that given sound. So we need to kind of intervene. We need to make sense of that space. Here's a visualization of a possible space made by thousands of these tiny sounds created by approximating the given sound. They're simply organized by comparing their acoustic similarity and finding a two-dimensional, in this case, reduction to that. So the next task is in a way to find intervention in that algorithm. So we need to kind of go and iterate and find the next way to work with the material. One way is simply that to traverse that space. For example, we could start with one sound and then delete that sound from the space and find the next closest sound and iterate. and so on. So you can see here kind of the color gradient. I don't know if it's visible on the projection. Is kind of the temporal development of one specific structure. And then the second thing that I did in this piece is that I condensed that structure, condensed in the sense of intensifying the density, layering these kind of processes, and trying to see if after we have created a couple of layers, we can simply reductively thin out the structure and achieve a specific result without my kind of will or my kind of arbitrary decisions interfering that much with the process. So one other thing that happens here that I think is very particular for algorithmic spaces or for this kind of working a space is that each representation that we encounter offers a new, a different kind of affordance or representational possibility. In this case, since the building blocks are formulated in the supercollider programming language, we can first observe that all these sound structures can mostly last infinitely long. So even though I gave it a short segment of speech, let's say 10 seconds or 12 seconds, these oscillators, they can run for longer time. So we already have a kind of completely new representation. The other one is that we can split the signal. We have now a parametric space that we can change after the fact. So I can introduce this highlighted thing that is called a multi-channel expansion, for example. I can create a spatial structure simply by digging into the parameter space. This is a system that I used yesterday in the concert. And what I'm showing here is an example of another kind of coupling of spaces. So I used some of the sounds that I discovered through this genetic programming. Now I have a parametric representation. For example, I decided that this one has 6 parameters, this sound structure. And now I can put it into another space, which is my kind of improvisational instrument, which is a physical space on the screen which organizes my sounds. So algorithmic spaces are always susceptible to translating into other spaces and to coupling to other spaces. So what do I mean when I say condensation? I already mentioned condensation as a way of compressing something, making it more dense. But also, I think, so my background is a lot in sound installation, not so much in music also, but I tend to work more in sound installation, which is which comes basically from the space as the prime medium which you encounter. So condensation as a physical, as a term from physics, it means that one aggregate state turns into other aggregate state. And when we talk about our own perception of condensation, it means that something crystallizes, something becomes some atmosphere becomes attached to a specificity, to specific objects, to specific surfaces that we find. This is a sound installation made in a ship that uses different spaces, physical spaces, in which these genetically programmed sounds are distributed. And therefore, you kind of allow the visitor to explore the space by going really physically through the different parts of the ship. And also, as you can hear, there's a colorization of the sounds. That's because all the sounds are played back through metal objects. So basically, we can take a specific thing and give it an additional surface, or kind of project it through a surface. When we talk about the term space, we usually mean the generic space, or an abstract space, or a non-particular space. So I don't know if we should talk about algorithmic spaces, or also about the condensation as a transition to algorithmic places or algorithmic sites. That is to say that there is an individuation of spaces that has to do with the coming together of that particular abstract space with our environment, with our background, with our experience. This was also part of this sound installation in the ship. There was one room which was dark, and it showed the process in which the sounds had been generated, using something that while the sound space is kind of a space that has been picked up over time, accumulating all that sounds. The process by which the evolution in the genetic programming happens is kind of lost for the viewer, for the visitor. And so what I try to do is bring also that kind of aspect back to the work. That is to say, there's in each space is kind of created by a process. It's not just there, it just doesn't come into existence without anything, but it's something that has to be built up, and that can be also explicated in the work, making this aspect more understandable. So what I have been trying to go, the route I've been trying to go is to say that we can come from this idea of formal aesthetics, or the idea that algorithms are mainly defined by logical reasoning, and then we can kind of celebrate this kind of formal reservoir that they have. But there's also other ways to understand them. I have just noted one. I have written them with question marks because one can discuss what if one agrees with that or not. There's, for example, the speculative aesthetics that Luciana Parisi is talking about. That is something that has to do with the idea that in computation itself is a novel mode of reasoning, which brings agency to the process that is not predetermined by intentionality. On the other side, interactive approach comes from Karen Barat and talks about the exchange between humans and machines, so that the agency always requires this coming together of different players or actors. One way of understanding how space is created I find very interesting comes from a British electrical engineer by training, but a mathematician, George Spencer Brown. He wrote an influential book in the late 60s called Laws of Form. And he kind of developed a specific calculus based on the idea of transitioning from an unmarked, pervading generic space to a particular space. So making decisions creates space, and it creates a specific boundary, and we can then connect by making the next decision and making the next decision. So I think this is an interesting pair, the unmarked space versus the marked space, which you might think about as a site. Another interesting idea about space is that relates a little bit to this interactivity maybe, is that when we work with machines, that we create a very particular situation. We couple ourselves to machines. We write code, or we rewrite other people's code. And we come into a situation that, according to Hans-Jörg Reinberger, could be called extimate. He's looking into experimental systems. So what happens when a scientist works in the laboratory, but it could also be, by analogy, applied to artistic research, I think. So the kind of this distinction between my space and the machine space, or my presence and the machine's presence, is kind of strangely twisted by the machines becoming strangely intimate, although they're exterior to ourselves. And of course, another element that we might look into, let's say, software studies or research that looks at how computers are used, how we think when we use computers. There's, of course, the metaphor of the workspace. So when we compose, or when we create, or when we program, we don't know yet what the outcome is to be. So we need to organize elements, and we need to be able to come back to them. So we produce a space, a digital or analog workspace, where we can leave objects and we are happy to come back and find them later. So an interesting question, I think, for artistic use of this kind of algorithmic spaces is how can this kind of workspace systems, how can that be made perceivable, how can that be coupled or made translatable into pieces? How this way of working, organizing things can become part of the work. Here's a photograph of another sound installation. This is in a little bit like our improvisation duo is kind of a negotiation between our two systems and our two spaces. This is also this piece called Körper is actually a series. There's already multiple, but this is the first one. Is a negotiation of what happens when multiple people work on the same piece. In this case, again, David and me, and also to offer a physical space that is intimate somehow to the viewer. So it's a sound installation, and also has a video component and has a sensory component that looks at the movement of the visitors around the object. What it's doing is kind of translating that presence first into our internal spatial representation, that is, and then played from one system to the other system, which makes a sound sense out of this thing. This piece has 5 channels. And what I find very particular about it is that because it's a kind of human scale object, you can approach it and you can open the acoustic space. That's for me one of the most interesting things about the speciality of sound installations. Unlike the concert space where everybody's usually seated, or maybe there's a performative element where people need to change place, but basically everybody has their position. Here you can kind of co-create the space by approaching the object and opening up the multiple speakers. The sound you're hearing is again produced by the dynamical system that David was presenting in the previous talk. So what is this installation doing? It's picking up relative motions of people that approach the objects using ultrasound feedback, or ultrasound, let's say, not feedback, but an ultrasound signal that is bounced off and thus produces a Doppler effect. This is a sonogram, time is from left to right. And the center frequency is basically the undisturbed signal at 40 kilohertz. So when a person enters the space, it modulates the inaudible sound towards either direction, above 40 kilohertz or below 40 kilohertz. And then the computer tries to create a particular space out of this gesture. So space is created by presence, let's say. In this first stage, where this kind of internal space that you don't really see or hear directly is created, I used one algorithm I want to talk about briefly. It's called the growing neural gas, which is a very simple unsupervised learning algorithm. Unsupervised learning means the machine doesn't really have a specific goal or a specific training to go into to one direction, but it's kind of adjusting to an unknown input and tries to organize it. A little bit like the self-organizing map was in the sound space that you've seen before. And why I wanted to bring this up is that I think it's also important to understand that the spaces that algorithms kind of create, they can take different forms in translation into different works, even though the same structures underlying the kind of consequence can be very different. This is a scan of a pathway. It was used in a different piece called Meanderungen. In this case, we were interested in scanning the surfaces of cities. And the algorithm, this G&G algorithm, is used then as a way to understand how we can create, again, a sound structure from a from a two-dimensional image without resorting to simple solutions like scanning the image in a specific with scan lines or taking the spectrum and so forth. So what it's doing is kind of rebuilding the cracks in the pavement and then giving suggestions of how to traverse the image, which can then be converted into sound. An entirely different rendering is shown here, which is part of a catalog project. So this is actually a printed text. It's also folded, which is not it is visible. You can see a bit. You can see the fold lines here, for example. So every 2 columns, the paper is folded. And what I was interested in is to understand how this growing neural gas algorithm, which organizes a space, can be used to connect the different parts of the text. So the outcome is entirely different modality, entirely different affordances from the previous example of the same algorithmic disposition used. But again, it produces its own kind of perceivable space through the particular translation that is the typographical movement of the text across the boundaries. And now we're back to the sound installation, to the Körper sound installation, to this object that you saw hanging. On the left, you can see a spherical mapping of the ultrasound signals from the different channels. There are 5 channels, so there are 5 signals, and each of them is kind of creates a Voronoi area on an imaginary sphere. And then what the algorithm is doing here in this case is trying then to rebuild that signal. You can see this on the right-hand side. It has a limited number of nodes, so it has a limited memory, if you like. And therefore, it needs to adjust to the changes. And what you see here is then used to communicate to David's system and kind of go into these oscillators and couplings that you've seen in the equations. So the idea of marking, unmarking space, so making decisions, that is a crucial element of creating space, is the procedure by which decisions are made. In the terms of George Spencer Brown, he had this idea of the unmarked and the marked space, and he calls the unmarked space just space, and he calls the marked space form. And if you look carefully, you can find this kind of duality in many different authors. So Reinberger, that was the person that introduced the experimental systems and this extimacy idea. He says we are in this unknown situation called experiment, but we stabilize certain things. They become technical objects. Or Niklas Luhmann, as a sociologist, he defined this kind of process of going from one space to the other as going from medium to form and so on. So for me, that is interesting because we are interested in looking at algorithmic process, and process is basically very difficult to observe. Our process is about becoming. It's not about objects that you can fix and talk about easily. And so we need a handle to do that. We need some tricks, or we need some tools to observe processes. And I think this idea of the re-entry, that is, I didn't talk about it much, but the idea of this unmarked, the marked space becoming another marked space, that Spencer Brown calls a re-entry. That happens when you cross a boundary. But for example, if you imagine that these are pieces or studies or objects that we create, they have their own kind of temporality, which is, sorry, the graphics are a bit weird, but this kind of spiraling is meant to signify the process of working on a piece, which is not linear, but is kind of iterating, coming back and making changes. But but if we want to learn about the algorithmic as a medium, as a space that enables other spaces, it might be useful to look at the gaps that happen between one instance and the other. So the idea of the iteration that is at the core of algorithms, we can also identify it in the way we work over time. We go from one piece to other, or we rework a piece. And one suggestion I have is that to look not so much at the boundaries of pieces, but to look at the drifts and the shifts that happen between these instances of pieces. And that's it.
Thank you very much, Hans-Holger, for your talk. So, are there questions from the audience?
I would like to ask, yesterday in your performance, why you choose not to project your systems?
This project basically exists since 2014, roughly. So we have been improvising with these two systems. And you could say in this kind of Reinbergian terminology that they have technical subroutine. They're still our epistemic objects, but they are relatively stable. So we have kind of obtained a practice with using this system, which is always an interesting question when you use computers for making music, because unlike instruments, and I would also not say that a computer is an instrument, these are a little bit less stable in the sense that they are constantly maintained and changed and so forth. That said, so we never had an occasion where we had the feeling we should project what we were doing. There were some instances, because usually we like to actually sit in the audience, because simply from also acoustic perspective, and so people kind of accidentally can see what happens on our screens. As far as I know, that nowadays there's not much that you can see anymore on David's screens, because he's basically playing with the ears and with the controllers. So the system is, in an early instance, it had still visualization. So we worked sometimes by incorporating the visualization and also the interface I'm using in a slightly abstracted way, that it becomes less a functional interface and more an aesthetic object to give people an idea of what happens. And we have been experimenting with the visual aspect of the performance in basically almost every instance we do. We think about how we're going to do. Are we going to show a video? Sometimes we were using pre-rendered or some half real-time, half non-real-time videos that were kind of incorporating some of the data that was also used to drive the sound. Sometimes it was more abstract, sometimes it was a bit more graphical. But for the same reason that we don't, for example, put a speaker with each person that you can do when you do improvisation. You can place speakers around each voice, and so the audience can identify a little bit who is kind of responsible for which part of the overall sound. And that's kind of tricky in this project, because as you saw with the equation in David's case, the one signal goes into a feedback circuit of the other system, and therefore it's very difficult to say that a specific sound came from this machine or that machine. I mean, you can still do that. They are still separate entities, and they play on different loudspeakers. But we're not, for us it's interesting, this kind of coming together in the sense that we create an overall sound in which there shouldn't be really a distinction in the sense of instrumental distinction between two players, let's say. Ideally, I would like to develop this kind of duo to go even more into a mode where we are doing less intervention. So this was really like an improvisation with a lot of interference with what is happening. But I actually would like it to move into a direction where we do less and less and just initiate some processes and they can be more autonomous than they currently are. I don't think that showing that interface helps the audience to understand what is, I mean, it helps in a certain way to understand technically what we're doing, but we also know that the visual sense is very strong, and that means that we get easily distracted by, in terms of our attention economy, by the visual aspect. So if you put a visual aspect, it needs to be really, really integrated and balanced with the sound. And I don't see it currently that this kind of part of these systems. So that I don't see, that's why I simply don't see a reason why you should see these systems. I'm happy to explain to somebody after or before concert what is happening, and so they can. So I think there's multiple channels to understand this. One is to talk to people and read about it, and the one is to be in a concert and experience it, and there I would prefer to have the focus still on the ears and to simply hear what is happening.
All right, there are 4 questions, but I also have one question, and it's very, very trivial, because referring to the visual component of your piece, I remember your piece quite well. There were visual parts, right? I mean, you had 2 blinking objects, binary light pulses. So what were these all about?
Okay, so this is basically, so I take each of these kind of occasions as an opportunity to try how we can kind of add some element that does, so should we just play in the dark and that's it, or maybe not, or should we add an additional performative element? So that was one experiment, let's say, to say each of the systems has many, many processes that are coupled and are doing complex things. Well, what if we simply reduce the information to a one-dimensional element, which is the light? In this case, one light from my system, one light from David's system. And it was, for me, an opportunity to try what happens, for example, in my case, what I'm doing is like I'm editing different nodes in a graph of a sound structure. And the light always basically follows where I am in which object I'm working on. That's why it may abruptly change the pattern depending on what I'm doing. So it's kind of a slight emphasis on showing this, kind of revealing very, very little, something about the process I operate the system, let's say, without giving you too much of an overwhelming thing. You can divert your gaze or close your eyes. You don't need to follow it, but maybe it gives you a certain additional hint about what might happen or not, without imposing a strong narrative maybe on the sound.
All right, thank you very much. So now that I asked my question, I think there are only 3 questions left. So this is why I hand over the mic to Florian Hartlieb.
Thank you. Thank you, Hans-Holger, for the talk and the performance yesterday. I have just one question to the speculative aesthetics, which I like very much as a term. And so the question is, how brave are you during a concert? When, of course, you know your system very well, but do you always know what comes out when you play, or are you sometimes really make experiments during a live performance?
I mean, so being an improvisatory setup, of course, the specific trajectory, let's say, through the temporal and temporal space and so forth is not pre-given. But that's why I was talking a bit about this epistemic thing versus technical object. I think it's kind of oscillating between, if it was too open, if it was a real experiment, let's say like a physicist would do, and they wouldn't know, they have to do multiple iterations to come to something. you can also do a performance where you kind of, let's do it 5 minutes and we retry and we retry. That could be an interesting endeavor, but I think we're kind of in the middle in that sense, that we have this embodied knowledge of these systems because we wrote them and we have used them many times. So, and I don't use any additional, I don't use headphones or anything like that to know what's happening. I'm just listening and trying to figure out what is happening. But through the experience and through the practice, of course, you have a fairly good knowledge of how the system behaves. On the other hand, I think it's, so we have, let's say we have this kind of possible space of what can happen, and that is not infinite, of course, but it depends on the systems we use, and the building blocks they use, and the formalisms they use. But I like most of the concerts most where something happened that I thought, oh, that was interesting, we never did that this way. But I think that's kind of common to any improvisational context, that's what you aim for. You aim for a balance between controlling what is happening, or at least say giving it a specific direction so it doesn't get out of hands. It's kind of not the experience just for us on the stage, but there's audience, and they also should participate in this experience, so I don't want to be too disruptive in that sense. But I'm trying, in a way, to understand what I'm hearing and to make interventions that might move the space in another direction. If that is speculative, so perhaps again going back to this this idea of going from instance to instance, that is to say, there's the experimentation or the speculation is not simply to say that is all happening in these 15 minutes. But it's kind of a process that happens also between this concert and the next concert and so forth. I don't know if the metaphor of the scientific experiment or applies to a concert situation that much. You can do it probably, but maybe that's more suitable for an exhibition where people can decide how long they want to pay attention to an object or a situation.
All right, thank you very much. So I think there are some more questions, but I would like to ask you to ask the question later.